Right. Hello, everyone. Thanks for joining the very last session, well, the last planned session for the VPP learning group. Today, we'll talk about the tech aspects, which we're definitely not going to have enough time to get into any sort of good detail, but we'll do our best. We are joined by Eugene from Belawatt, John from Leap, Wyatt from Gradient Energy, and Brady from Energy Hub. And why don't you start by introducing yourselves? Tell us a bit about your company, what sort of product you provide, and if it's related, if there's a targeting of Resi or CNI or all of it. Eugene, why don't you go first?
Sounds like a plan. Hi everyone, my name is Eugene Granovsky. I'm a founder of Belawatt. We're an agency that works with utilities and energy transition companies that we offer typical full stack development and product management design services, but we tend to wrap it up into holistic products that utilities aren't able to implement off the shelf themselves. That turns into a range of EV and education and engagement tools for utilities, to a program that we built for New Hampshire around the transactive energy rate that they're launching, down to sales enablement tools for energy transition companies. Yeah, very, very excited to be here. And again, my background is in regulatory. I was a regulatory consultant for many years, and then picked up front end development. And yeah, here we are. Very glad to be here.
Thanks, Eugene. John, do you want to go next?
Sure. Afternoon or morning, perhaps, everyone. Hope everybody's doing well today. My name is John Houle. I'm a senior product manager at Leap. So for those that haven't heard of Leap, we're a wholesale markets access platform for other third-party or OEM companies that want their end customers to be able to benefit from the revenues and other ancillary benefits of grid services. So our platform connects the markets. Leap's here, our partners are here, and the end customers are here. We try to help them make money using the assets they have on site. We're B2B and B2B. So we're B2B, I should say, though our partners are B2B and B2C. So we service any and all loads that are will enable to participate in these energy programs that our platform supports. And right now we're active in, I'm going to get the number wrong, but 4 or 5 wholesale markets, and looking to expand all over the next year or two in North America. So that'd be Canada and the United States, and the aspirations to go overseas and in Asia as well over the long run. For myself, I've been in the energy industry my entire career. About half of that has been on the demand side or DSM management, energy efficiency programming, both in program development, regulatory, sales, what have you, consulting, and the other half in technology, holding various roles. And my latest is on the product side. I've had the benefit of working with, I see some familiar names on here, which shows how far this, or how small our industry is, even though I think now it's starting to grow really quickly, which is amazing. So pleased to be here and looking forward to the hour.
Thanks, John. Brady?
Hey, John. Good to see you. It's been a while. Hey, everybody. Brady Klein. I'm at Energy Hub, and I manage the market development team. So I happen to be the one person at Energy Hub that does similar stuff to Leap in kind of bidding demand response capacity into wholesale markets. But the most of what we do is helping utilities build virtual power plants. So we focus mostly on the peak reduction value that utilities can capture from running customer-facing demand response programs on all manner of DER assets, mostly residential, but increasingly CNI and kind of small and medium business tech-enabled stuff connecting to the platform. So I'll open myself up to some disagreement with my Leap friends, but like Leap for utilities is one way to think about it. Although we do work with Leap in certain places where we need to participate in markets as well.
All right, Wyatt.
Hey everyone, my name is Wyatt Makedonsky. I'm the co-founder and CEO of Gradient Energy. We build and operate vehicle-to-grid virtual power plants. My background is in software and machine learning.
All right. Cool. So we didn't have that many resources or so like homework for this session. The only thing with this video about those two Tesla engineers who essentially describe how they built their entire stack. And many people in the audience wonder, like, how do you build this stack for yourself when you're not Tesla? One of the big questions is, how can you do that when all the assets are so different, when you don't have full control over all the assets? Does anyone want to take this question to start?
I'll let Brady go first. I think you might be able to speak best, but
Yeah, it's that's exactly what I was thinking of when I watched the first half of that video, and hopefully we'll finish it. Although I shared it with our dev general, because I think a healthy contrast of VPPs against them is shockingly public, but super interesting for all of us to dig into. Yeah, our business is predicated on talking to OEMs and DER manufacturers that we're not owned by and don't own, or we don't manufacture technology. So creating a really easy way for folks that own DERs, whether that's customers who already have a thermostat and want to sign up for a program, or larger folks who have their own control of assets on site, like commercial industrial folks who control processes or have on-site process loads that are kind of more manual and less tech-enabled. Like, how do you translate all of that into one seamless pathway? And I mean, I think a lot of us on the panel probably have similar approaches to this, right? But like, the sauce is in normalizing an integration that enables monitoring and control across all of those different device classes and customer segments. And so creating a specification for an API integration is the way that we could dig into, like, the way Leap and Energy Hub have kind of approached this. Eugene, maybe you're doing this in like sort of a more custom way, but like, building APIs for someone else. But like, the answer is to build a pathway for others to connect to you in the way that allows you to capture the most value and the most, what is the 80-20 rule for being able to get as many DERs in your ecosystem as possible without losing too much functionality along the way. And where it gets really kind of interesting is, where does the functionality of a DERMS platform or a VPP platform have to end versus where does it have to start or end at the DER side? Like, if there are control knobs in both sides of that equation, who's actually enabling the control? Can the device be dumb if the control is on the top node or intelligent? Can the signal from the top node be dumb if the bottom node of devices is intelligent? And so, like, building a middle layer between those two that can easily kind of accommodate all those little nuances, I think, is the key. So standardization of that API, for the lack of a better word.
Yeah, no, it's no different over here. In fact, we're doing something a little bit different. I think transactive energy is more, or at least a transactive energy rate, as NHEC sees it or New Hampshire sees it, is quite similar to a virtual power plant with fewer rules. But at the end of the day, the interaction is the same. And even though we were technically building a lot of this from scratch, the end result is quite similar, because we, for example, used OpenADR as a protocol here, and I think Energy Hub leverages that quite a bit. And we didn't use it because we wanted to. We used it because so many market participants already do. And so if we wanted to, as a utility, attract aggregators and DERs, we wanted a protocol that they could already connect to using their existing system. So the incentives were quite aligned. We would have, even though we are OpenADR Alliance sponsors, we would have probably done something else otherwise if it was just completely up to us. But unfortunately, in this space, you really need to play to existing parties. I think I'll also say one more thing here in our experience, in that I think in a lot of other industries, technology wins out, the best product wins out. I think here there's another layer here, especially when it comes to DERs, and it's contractual. Some of the I think most successful companies are the ones, and products are the ones who can figure out the right agreements with the right other parties, which makes, unfortunately, the technology piece a second step in the equation. I don't know if others have seen it elsewhere, but yeah, at least that's our anecdotal experience to some degree.
Mm-hmm. Yeah, I think you both, Brady, you asked an interesting question, like, is it the smart top node or the dumb top node that wins? And I think the answer is yes, because you then take Eugene's point of like, where do the contracts and financial relationships lie? And the answer is it depends at what layer of, call it, the stack and the that you're talking about, right? So I know we're using the term VPP, and already we're using it a little interchangeably, mostly talking about utility services, but like VPP itself is a term that has been kind of stretched like pizza dough to make a pizza whatever shape people wanted, but really means some sort of aggregation, right, of DERs to provide a service to utility or wholesale market, or both concurrently. And through that, there's it could be a ton of different ways of dressing up the pizza, giving flavors, right, in terms of contractual relationships and intermediaries. And I think that's what's really interesting about our sector today versus, call it, 50 years ago, when VPPs started with basic utility demand response, controlling air conditioners. There was like nobody in between, right? There was nobody in between. The utility, the end customer, sort of physical device that shut the thing off when they wanted to, and now there can be many parties between whoever is paying the money and whoever is collecting the money by providing services. And this is an extremely dynamic sector that we're all in. And you'll hear many folks along that stack participating together, all calling themselves a VPP. And then, like, which leads the question that be like, what is a VPP, right? And it's now become like a different thing to a lot of people, which is okay, right? Ultimately, I like the generic definition of just a demand response, or sorry, demand side aggregation of assets behaving in a certain way to satisfy a buyer's needs. But to do that, you can do that in so many ways today, whether it's through utility programming, wholesale market programming, both concurrently. There might be an other that I'm not thinking about. And in each of those, there's different types of DER services that can be provided, right? Whether it's like energy ancillaries, capacity, etc. So it doesn't answer your original question, Benjamin, of like, how do we get control? I think Eugene and both Brady get on the point. Is like, well, control is only part of the picture. It's like, who wants to relinquish control, who wants to get control, what are they willing to pay for that control or be paid for it, and then the technology stack has to complement that, call it, business model or programmatic model as well.
Everybody feel free to unmute and ask questions, but I think Justin might have more follow-up questions. Sorry, I put you on the spot.
Sure, no problem. I was just trying to figure out which one. I guess to expand on that first question, I was watching the Tesla VPP video, and they have a very integrated vertical, they top to bottom, right? And so one of the strengths of their auto bidder was that they could balance the needs of the household, what they were calling local optimization, with the needs of the VPP or the customer of the VPP, which they were calling the global optimization. And so they pushed down a whole bunch of edge compute down to the various households and essentially gave them the information that AutoBidder was using. And then each household would individually decide how much it wanted to bid in order to contribute its capacity to the VPP, which sounds great if you can do it. And I'm sure it would be, you know, much more optimized than having some higher levels of abstraction doing that bidding. But I wonder, you know, it sounds like it's not terribly realistic to do unless you're a Tesla or an Apple and you've got that whole walled garden ecosystem. I was just curious, you know, where do you guys have the layers of bidding going on? Do you have some kind of intermediate hierarchical groupings that do a bit of bidding, or is it all just at the top? And if it is going down into the hierarchical layers, how do you deal with scaling that out?
Yeah. Great. I mean, I could do the leap answer, then I could give the John from other lives answer afterwards. But maybe I'll let Brady go first, because I think his answer probably gets back to my previous life, how you make these come together in real life. But you know, at Leap, what we do is it is a bottoms up type of build, right? Certainly, we have a market obligation that we have to satisfy from a capacity standpoint, and then we'll do our energy bids based on our customers' capabilities on that, you know, for that time specific time period, and we'll aggregate those into a portfolio, or more, you know, properly called a resource in the market. And, you know, we'll represent back to the market that aggregate bid of all of our individual partners as individual sites, right? So it's a very much bottoms up. But to back to that original question, like, we're kind of a dumb virtual top node in this at Leap, in the sense that because we don't have control, we can't say, here's how much energy we're going to get from you today, right? We more ask you, aka our partners, aka their customers, to give that back to us, and we'll aggregate it. And then some of our secret sauce is how we risk manage that in the markets, right? So on our side, we're the dumb ones, right? We are at the mercy of those endpoints behaving as they said they would, which, newsflash, you know, always, which, you know, that means we have to, you know, have a financial or a robust financial risk management framework in place, which is like maybe another flavor over here, but like contract structures and, you know, actual stacks. If you're in the market, or if you're providing like a different performance service, you got your risk management over here. So that's how we do it. But I know there's, you know, there is the inverse, where there's direct control or some like pseudo control, and Barry could probably speak to it better than I am. In my previous life, we worked with Energy Hub to do that. Like, how do you translate some level of customization to some like obligation back to the counterparty?
Yeah,
so,
I don't. Oh, go ahead, Wyatt.
Thanks, Brady. Yeah, so Justin, getting at your question, first, from my point of view, we're slightly in a different, we have a different viewpoint than some of the other companies on the panel. We're a third-party aggregator. So here's a utility, here's a bunch of EVs. We're the layer in between that coordinates everything. So getting to the core of your question of like, oh, smart bottom node, smart top node, how does that look? Being actually like writing all this code, a lot of the actual like the physical EVs, the batteries and everything are rather dumb. They're wide open to take whatever command is going to be given to them, and they're going to do that. So we have all the intelligence at our level. There are naturally scaling issues, but those are something that you can handle. One thing, I think I've talked about this on past calls, but there gets in our position there, you assume a certain amount of risk of, you tell a utility or perhaps the wholesale market, like, oh, we can provide, let's say 10 megawatts. If we don't provide that, then we pay a penalty. So we're assuming some of the risk for that. So that means that we have to intelligently manage that. And so there's a lot of interesting ways to do that that get more complex. I'm actually writing a paper on that, and I expect to publish that this year. I think we might have talked about it on our call, but for everyone, it's an interesting problem, and you can frame it as, not to get like too in the details, but you can frame it as sequential decision making, and that opens up a whole host of methods. Specifically, we use like deep reinforcement learning to optimize a lot of this, especially the real-time operations of it. And yeah, not to get too far in the weeds, but it's a fun AI problem if you want to manage all these different devices, doing all these different things, turning all these knobs at once, and responding to external signals in real time. So it can get pretty complex, but it's a pretty fun problem.
Yeah, I would. So I can probably answer the question a little bit with the way that we've even worked with Leap and the contrast with the Tesla video. Like, I think, not to go back to the economics panel that I missed, but I think the reasoning for why Tesla did what they did is because of their entire ambition and business model is to be the VPP to rule them all, with walled garden, soup to nuts, retailer, own the devices, participate in the energy market, and build pack projects that in and of themselves rely on market participation to pencil and get built in the first place. And so if you're Leap or Voltus or CPower or NL going out and aggregating sites, but like fundamentally what you're doing is taking risk in the market and then backfilling that risk and saying, bring me megawatts, where in this case it's, I want to build megawatts. How do I do that? And so the use case is completely flipped. It's like, I need a really good auto bidder thing so I can do this other stuff that I want to do. And therefore, I think that might dictate a little bit more of why, like when you have access to the data, sure, like you mentioned, Justin, that helps you. Like when you can take global and local and put them together, that's great. But I think the very nature of the business model kind of allows them and affords them and motivates them to want to solve that problem that way, as opposed to what John was describing, which was, let's go win 10 megawatts of capacity in PJM and then go figure out how to backfill that later on.
Awesome. Thanks. Sorry, John. Cool. All right. Well, I have another question, if that's okay. The point of integration with the utility or the DSO or the wholesale market, where do y'all fit into the wider ecosystem when it comes to bidding?
Sure. Ours is straightforwardly on, call it the market side, it's the markets and or utilities, and on the sort of devices side, it's what we call, again, our partners. We do not send signals directly to end devices today, so it's kind of and that's part of our business model. That's a choice we've made. There are a lot of folks that are OEMs most specifically, but also many third-party energy services companies that they want to run their own optimization on top, or want to have a specialized control strategy over that site or that device, and having another person trying to layer their own conflicts with the service they're trying to offer. So we're really offering just the market access to them, not the actual device control. So for us, it's pretty straightforward, sort of market side integration on one side and partner side on the other.
I'll just we're the exact opposite side. We are taking what the utility packaged together as a price signal and packaging it up for aggregators, specifically prices to devices, and doing none of the control that Wyatt is referring to. Yeah, it's going to go on a tangent, but it's not worth it.
And yeah, we're mostly focused on giving utilities a peak demand reduction tool that is, up until now, kind of the business case is built on the energy efficiency budget. It's the demand side management budget that says, you utilities in my state have to achieve X megawatts of demand response because that's worth X net present value of benefits, and therefore we can go spend Y dollars on demand response programs because it's less than, the avoided cost of all this stuff, procuring services in the wholesale market. So it's kind of like abstracting the wholesale value of the thing and then giving the utility the ability to build it on the demand side. So that's how our business model works. More and more, we're starting to see utilities try to squeeze more out of the demand side resource and kind of stack that local value of like using DR to manage their own kind of capacity allocation, transmission cost, which is what they use it for today, but instead trying to participate more so in energy markets or things that wouldn't be considered double counting. And so that's like, I think the frontier of all of this is figuring out that, I shudder to say like DSO of the future, but that true platform that's probably closest to what Eugene is building, which is like how do you build a thing that maybe starts with the utility resource on the demand side, but then works with a party like Leap to take excess capacity and bid it into the market, but also knows what customers want and is optimizing for their use case too. Like that true VPP that optimizes for customer, local distribution grid, and wholesale doesn't really exist. A lot of ink has been spilled. Like we're all probably going to try to build that thing little by little, but like the full value stack all being in one place across customer, local grid, bulk grid isn't really a thing today. It's just, white papers.
Yeah, it's hard. We have a few places where we're getting there in the stack, and there's some of our competitors that are also there, but it's in really isolated places. It's hard to do, not to abuse the term wholesale, but at scale or across markets. There's so many like rules or ways of managing these sort of, call it dual enrollments of DERs that make that really challenging to do across the board.
I think if the just to add to this, if the market continues where it is today, none of this would even get fixed. But I also think to Brady's point, you kind of led it, but I don't think you said it. Like this is not going to be sustainable for the next 5 years. I think that we're all going to be forced into some sort of non-wires alternative world where if EV trends continue and batteries just pick up even a little bit, solar trends continue, utilities are going to have to participate more in these, whether they are encouraging customers to participate one way or another. So I think this is a lot of these murky interconnection points and strategies are almost going to be resolved. I'm not smart enough to fix it, but I know that the world is going to resolve itself into some way, one way or another.
Okay, we've got a couple raised hands. Brian and then Ryan.
Hey, thanks. This is Brian. So John mentioned a little bit about some of these devices performing, unpredictably, sometimes unreliably, all over the place, and there's some degree of, financial risk management there. And for me, I guess that just brings up a couple questions on approaches to measurement and verification. And I'm just curious if the panelists can talk a little bit about their general approach there on M&V, how much of that actually falls on, your company as an entity, and then what kind of like challenges you face in terms of the latency of being able to verify that performance, and how that might tie back to some of that financial risk management and just your general strategy.
Good question. I know I've been taking a lot of the airspace up, so I make sure I give some to Wyatt and Brady, but I'm happy to give the Leap answer in a second.
Go ahead.
All right. The first thing is that, like, it depends on what the market or program rules are for M&V and settlement. Like in some cases, the Texas being a great example, like they do it all themselves, right? Like the market has access to Smart Meter Texas. They know who the customers that are participating, and then run the full sort of M&V settlement by themselves, right? So we don't even need that telemetry or data to operate the programs as a base level. Great to have, nice to have, allows us to do more things with our partners and their customers, but not necessary. So that's like absolutely on the, call it the easy side for us. On the absolute other side is, yeah, we either gather meter data, utility meter data, or device data, and use that to run two things. Usually it's baselining and performance pipelines, and we use that data to submit that data to the program operator for them to confirm our savings and pay out our payments, which we redeem back to our partners. But we also use that data to that sort of first question around performance, actually try and reinforce behavior with our end customers. So we don't have direct control, and frankly, we don't even have direct contact with these end customers at Leap. It's rare we talk to an end customer, but we'll provide our partners the data showing that their customers' performance, and incentivizing them to incentivize their customers to perform better, or adjust the position that they're taking with us in the market, more tactfully than like with their market nominations. So say it's a 1 megawatt site and it's always performing at 500, that will hurt us and our partners at some point. So we want them to adjust that to a more reasonable level, or the inverse, right? If they're performing really well, we want to allow them to reap those rewards. So it's really, in our case, it's kind of a data loop that we're trying to build to reinforce behavior. But again, it's not a hard control that we're changing because we don't have that capability. Does that answer the question, Brian? At least from the Leap side, or is that helpful?
Yeah, no, that is really helpful. And the follow-up there would be just on like the latency aspect of getting that data. Like how quickly are you actually able to get that information? And I'm thinking of like there's this article in Canary, I think back in the fall, about I think specifically C-Power was mentioned, and how like sometimes it can take like 4 weeks to get that performance data, and it just really hinders their ability to get the most out of those relationships with their platform partners or the customers, depending on who they're interfacing with. So is that something you're also seeing?
Yeah, I think in those programs where kind of like the utilities are doing those savings calculations, performance calculations themselves, yes, there's a decent amount of latency could be actually measured in months. On the other side, where we get the data access through meter data, most places we're getting that daily, give or take. And then device data sort of depends on what our contracts are with our partners. But and here I'm talking really about like capacity and some energy programs. Certainly when you get into ancillary services program, the telemetry requirements are like way higher. It like measured in sort of second time between the device and the market. So that's kind of a whole other ballgame, and the tech stack to service that is completely different.
I can speak to the utility demand side management, M&V, which for the most part relies on meter data that the utilities either own because they've deployed AMI, or because data loggers were installed by a third-party evaluator to come up with a stratified sample to do it themselves. But the way that utility DR programs run is sort of like an adoption of what was the California standard practice manual for doing M&V on DR programs, and the same kind of market baseline is used, whether you're selecting 4 of 5 like days in MISO, or 10 of 10 and 5 of 10 in New York. There's all these different ways to do it. They're generally pretty similar. Texas uses a regression model. So like the meter data that's used, like there's a lot of different flavors of it, but generally whole home meter data is the standard practice for doing this. And so when we're talking about DR though, we're getting a ton of device telemetry. Like Wyatt, you're getting EV data. Like Eugene might be integrated with devices and getting and doing transactions based on information that they're getting from their device telemetry. So like that, you might as well throw in the window if you're talking about like literally throw it in the trash if you're settling today in the market or with a utility. Like sometimes the third-party evaluator for our programs will be like, oh, sweet, you have thermostat data. Give that to us. We're more than happy to compare it to whole home meter data. But what really matters is the service delivery point, the meter. There's so much to unpack around what could be done to instead use device level sub-metering to do all of the stuff that we've been talking about. But we're still really early on convincing regulators and state commissions and markets that revenue grade device telemetry out. I mean, so far we've convinced them that solar and inverter-based resources are almost there. But everything else, like settling in the market on thermostat runtime, is like, that's a pipe dream in my view. But hopefully I'm proven wrong. But like that is the next frontier, I think, of being able to convince people that sub-metered telemetry is actually as good as using, whole home 98% tolerance revenue grade metering.
Yeah, so another perspective of where we're coming from is we're talking to each and every device, so we can generally get, all right, 50 kilowatt hours were produced during this 5-hour time frame. And so we can say pretty confidently that, oh, this amount should be paid out. And an interesting aspect, I guess, that since we're working directly with customers, is there's a user experience aspect to measurement and verification, where the sooner you can close the feedback loop from going from end of event to customer getting money in their pocket, the higher the likelihood that they're going to participate in future events. So that's an interesting problem of its own. But we try and cut checks soon after the event and just depend on the meter data itself. Obviously, whatever comes through utilities takes longer, and that gets a bit more complicated. It really varies, and sometimes you might have to go through like a third-party API, and that becomes kind of a mess. But yeah, we try and rely on devices themselves and close that feedback loop as quick as possible. There sometimes are differences. They generally aren't much, but what you can do from another interesting perspective is the devices on the measurement on the devices themselves are going to be pretty accurate, but it may not be perfectly accurate. It's like so many things, like not to get into the nitty gritty, but it's essentially just an estimation of a specific state. And so what we do with some of this to cut checks sooner is you can fit a probability distribution to it and say like, all right, well, pessimistically, you produce 48 kilowatt hours, optimistically you produce 52, we're going to pay you for 48. When we get the final verification data, if there's a difference, then we can just credit your account for the extra amount. But make sure to communicate that throughout the way to help improve the user experience. The user experience is like an interesting aspect that doesn't always come across, but if you're boots on the ground, it comes up.
Yeah, I think we see both sides from what Wide is seeing from like the aggregators that we connect to, and then I think we didn't really introduce this, but the fact that New Hampshire is a cooperative is allowing to treat these devices as, to Brady's point, revenue grade. I think the long I think path, or where I'm hoping this will go, is utilities will be incentivized enough to root for more revenue. We're treating devices as revenue grade. I think a couple of years ago, Baltimore Gas and Electric had a pilot where they treated EV chargers as revenue grade. I actually don't know where that pilot went. I couldn't believe it when I saw it.
We run
when
it.
I saw the announcement. Do you?
Yeah.
Oh well, I've been looking for news articles on it because I thought I lost my mind because I haven't seen any news about it since. But yeah, that is very, I think, quite rare. But I hope is a kind of peek into the future. As long as the electrification aligns with utilities and regulator interests, this theoretically should work. But of course, in theory, there's no difference between theory and practice, and in practice, there is.
Yeah, they had to waive their Code of Maryland regulations to allow for level 2 EV home stations to be considered revenue grade in lieu of installing supplemental metering, which would have cost more. And so I've been on the AMI side in my past life as a metering person at IBM, kind of helping roll out those systems. And even though we always complain about how long it takes to get the AMI data and how long it takes to validate and edit and estimate and all that stuff, fill in gaps, I still think the EVSE world is a little bit further behind the metering world. So I think it is appropriate at this point to not consider metrology from electric vehicle supply equipment the same way we look at it with metering, although it's appropriate to also pilot it. And so I'm glad that BG&E fought for that.
Ryan, you want to go ahead?
Sure. Yeah, I was wondering for the sort of aggregator of aggregators model, sort of the Leap and Energy Hub approach. You have sort of a capacity commitment or an obligation that you've made, say in the wholesale market or to a utility. And I was curious how that gets kind of broken down into sub-products that effectively get kind of auctioned away to the various device level aggregators. So for instance, let's say that the aggregator of aggregators has made like 100 megawatt commitment for 4 hours and has won that. I can imagine you could take horizontal slices of that. You could break that into 1 kilowatt pieces or something like that, auction those away. But I could also imagine taking vertical slices and auction away hour-long segments of that 4-hour event, or even 15-minute segments of that 4-hour event. And I was wondering if it was basically that simple of sort of breaking it into a grid of vertical, of little cubes that each represent 1 kilowatt hour for 15 minutes or something like that, or whether there's something more sophisticated there where different devices can respond for different lengths of time, and there's value in kind of like optimizing the sort of size and shape of those sub products and kind of tetrising them together to meet the overall commitment.
Yeah, it's definitely a Tetris game. That's probably a nice way to play it. I mean, without digging too much into the algorithms and the logic, business logic we use, that we try and, again, build that portfolio to meet our market obligations. And of course, resources have different capabilities, or assets have different capabilities, so we can kind of take those into account when we're building up that broader portfolio. Yeah, the auction model is interesting, like turning around and selling slices. Not what we do. I don't think that, if I wish the market was that saturated and we had that much business, that'd be a great problem, but I don't think we're there yet. But an interesting idea. But yeah, the behind the scenes nuts and bolts is akin to that, right? We're trying to build, we have an obligation that has, a shape to it, right? And we're trying to bring as many things in and fill as many holes and Tetris it together to meet that shape. Sometimes we're not quite there, other times we're exceeding it. But we do our best to try and meet that obligation. Of course, it's kind of like we get that in some cases years out. So the classical aggregator model, which we kind of are on the market side, has that sort of challenge, right? Where you take a forward obligation that you can adjust to a degree as you near your actual delivery. That I'm not on the market side quite as much, so I'll leave it to the markets guys. Maybe they can join next time. But that has its own set of challenges. And again, it's all called the financial risk management engine that's kind of happening in parallel to our actual product of connecting the customers to the markets.
Yeah, I'll offer so I think the problem space that you laid out is much more of a market portfolio and risk management question. But I think there's an interesting, if you were to pivot that to the utility world, it's not so much we've committed to give a 100 megawatt resource, so we've got to deliver it, but it's sort of like get all the capacity you can get in the program up to a certain cap. Maybe that's budgetary. Maybe you've got 80 megawatts of thermostat capacity, a couple megawatts of EVs because it's still early, maybe a CNI portfolio here. But I think your problem is really interesting when you think about it in the context of network management, because today for peak reduction, it's just all call. It's really not sophisticated. It's just take what you can get. Hopefully you get it. And once you know that resource size, you start to rely on it. So, 100 megawatts better be 100 megawatts next time, but it's not like slicing and dicing. But I think where it does get really interesting and where all the AI and ML and PhD solutions come into play is when you're starting to think about, give me, the ADMS says, give me 100 megawatts of capacity on feeder XYZ for 2 hours tomorrow because I see a thermal constraint on circuit, whatever. And then we have to go decide, how do we turn the dial across all of the device classes, like you said, vertically or horizontally, to get that 100 megawatts? That's probably too many, like 2 megawatts on circuit 1, 2, 3 for 4 hours. When you have enough capacity across EVs, thermostats, batteries, solar PV, and whatever. And that all just comes down to, first question of this panel, getting the data that we have from devices, modeling the aggregate capacity that you have available, and then using your secret sauce algorithms to optimize for some objective, whether it's flattest load shape possible, least cost, whatever that is. But like creating the objective load shape with a multi-DER portfolio, I think it's a lot less market informed, right? It's much more like, how do I either inconvenience customers the least or do it as quickly as possible? And so then it just comes down to like, what is the utility actually, what do they need? Do they need it in 10 minutes or a day ahead? But what I could say is that once you know the current status in real time of all of the things you have connected to you, and you can build this, like, what is the load shed I could get if I called an event for 2 hours now, an hour from now, 2 hours, and you can build that like what if scenario. that's when things start to get really cool. So we acquired a company, Packetized Energy, that kind of does that. And so, happy to get real wonky on the kind of packetization and randomization strategies that they're using. But yeah, good question.
Do we have any more questions?
Sure, I got one more. I mean, as a, can you hear me okay? Okay, sorry. As a software engineer, I'm always thinking about open source. How laughable is it to be talking about that right now? Or are there parts that can be open source, or is that all just, years away as we kind of pick things off one at a time and tackle special cases, then work on the generalization, etc. And is there a goal for that, or is it just so far out? It's more just coffee conversation right now.
No,
Can I quickly add on to that? Just what about open standards? Like standards, period, so that anybody who wants to build open source has the potential of it being relevant, given whatever the market layout is.
Yeah, we're pretty good at open standards, John. Eugene mentioned OpenADR. Like the problem is, like, open standards can get implemented in infinite ways, and they're not really standards. They're just interpretations of standards. OpenADR is implemented in 15 different ways at 15 different companies. So it's helpful. It's open source in a way, in that you at least can come into a conversation being able to tie two pieces of software together from a better starting point than you are from scratch. Yeah, green button's another great example. Can be implemented entirely differently by different utilities, although there is a standard. Open source, though, I think not intelligent enough to speak to the benefits in general of it, but like Camus, sort of DSO, TSO platform, open source. Recurve, they use open source methodologies for doing a lot of what they do. I think it depends on what component of the VPP service we're talking about. So like methodologies for measurement and verification, 100% open source the crap out of that. Like there's no reason we should be private about our secret sauce to measuring something, when the whole point of it is so that we can all get on the same page that we did the thing we said we were going to do. But integrating with device manufacturers, like a lot of the value that the industry can provide is the secret sauce in intelligently controlling devices the way that you think they should be controlled. And a lot of the device manufacturers have their own, John, you could speak to Ecobee doing this. Like there are proprietary ways that the device manufacturers want to do this. So like, I think we're a little bit further away from breaking down the silos of device control, but we're pretty close to showing other people, hey, here's what we said we were going to do, and here's what we did, and making that all open.
Yeah, I'll speak to the OEM side. I'll give 1 second answer to the market side, which is like, it would be fantastic if they all worked the same and had like an awesome system everywhere. I think that's kind of like a pipe dream for a while, just because every wholesale market operator wants to do things in some sense their own way. So we're a while away from that. On the OEM side, and I'll take off my Leap hat and put on my half of my Ecobee hat, even though I don't anymore. But they're in the team that created these like proprietary optimization algorithms. We did that was twofold. One was providing increased amount of services to our partners. Actually threefold. Second was standardization of customer experience. So like if it's an energy hub versus an energy hub competitor A, an energy hub competitor B, and each customer gets a different experience, those are customer centers. Well, confusing really fast. So we realized that works fine at like 20 programs, utility programs, not so good at like 100, 120. And the last one is frankly a business model question, right? There's a lot of folks that are like, let us use what we call the consumer APIs, or sort of those like more open, freely available APIs that are, some people have layered solutions on for free, but recognize the business model. Everyone in that is, right? The OEM has to maintain them for free. to no benefit, and then deal with all the backlash because it's their device on the wall. The person in the middle doing the controls has to hope that the OEM doesn't change anything without telling them, without blowing up their business. And then at the end of the day, the top person buying this energy resource has to hope that this, again, nothing in that stack changes, or they don't have pissed off customers because of a bad experience for a program that they might find out they're part of. So there's actually a commercial question, kind of back to this original part, like how can Tesla do all this? Well, in the walled garden, it's much easier. When you have there's like commercial questions that start to happen at every layer. And I'll say like the energy hubs and the competitors have done a good job being willing to work with these teams that say, I want a pseudo walled garden. Like I'll give you a path in, and that path is extremely prescribed. That path is layered with the business model, but it comes with some like contractual obligations to the OEM, some level of promises to the aggregator, and some quid pro quo on both sides, as well as protecting the customer experience. So that as suboptimal that model seems from like the research side of the world, and I'm happy to have conversations over beers of conversations I've had with regulators that hate that model, rightly so. Like there's people in between that are keeping this whole thing from working together. If everyone would just play along, it would be great, but like commercially that just breaks apart super fast, right? Because you're asking somebody along that's to like all play along, all do it for free, and we're not all Google and Amazon here that can just blow money. Like a lot of business, like these grid services programs that have to stand on their own to a degree, or Leap or Energy Hub's case, like that is what we do as business. So there's a tension there. Well, I know that's not exactly what you asked, Justin, but it's kind of a counterpoint to the open source question that like does come up frequently.
Yeah. So another perspective on this is, like, Justin, I'm also an engineer. I was, like first getting into this space, like when I was starting Gradient, like I was looking a lot at like what open source software there was, and there's barely any. There's a few reasons for that. I mean, in the future, like we have some open standards, that's good. And that's probably the extent of everything that's going to happen. One of the big concerns with open source is security. Now, like we take, for instance, like Kubernetes, like that's obviously a very secure system. It's, even though it's completely open source, like everyone trusts it, everyone runs it. But with open source software, like companies have a real concern that, especially when you're dealing with critical infrastructure like utility, that the code can be studied and exploits can be found. It's a risk that they're not always willing to take. So if something's open source, they may think twice and have some hesitance with it, which, like coming from a software background, like I love open source and it sucks, but that's just how it is. So it seems like open standards are really just going to be the way, but that could always change.
Eugene, did you have something to add to that?
Yeah, I think I'm still struggling here with connectivity, but I think from our vantage point, we've actually tried to open source quite a bit of our work, especially in the early days. And I think a lot of the models that work in other industries don't quite work yet here because of the volume of software engineers that can just do whatever. There isn't enough of a bottoms up strategy in most of energy companies that works well in other industries, but not here. Engineers at energy companies don't typically get to pick what program they participate in or what protocol they use. It's often made at a business decision level. And like I said, there's just not a volume of engineers, and in my opinion, at least, the standpoint. And then to double down on Brady's point, like again, OpenADR, big fans of OpenADR as a protocol. I think Brady threw out 15 different iterations. I would argue that each, if you look at the U.S. from a regulator standpoint, and then overlay a map of the utilities and the DR programs that are available, and then overlay a map of the ISOs and RTOs, you're just going to see that each even demand response program starts looking like a one of one. There are a lot of, maybe 80% is the same, 90% is the same, but then there are enough differences that you can't just open up a
a new, I guess, fork a repo and just get started right away. So I think that there are just fundamental challenges to the way that we have our grid constructed today, and to getting to too much success open source. Even again, we've tried it and wished it could work better ourselves quite a few times.
All right, that's the end of the hour. We're gonna get kicked out by Google in a second. Thanks everybody for joining. John, Brady, Eugene, and Wyatt for answering questions. And we'll keep going in the conversation on Slack. See you next time.
Thanks a lot.
Thank you all.
Thanks.
Thanks for organizing, Ben.